In this video, I will teach you the fundamentals of containers in just a few minutes and how you can start in this world. And we will start right now. Hi, my name is Ander Moraes, and if you would like to learn more about Java, containers, the topic of this video, microservices, and cloud native related stuff, make sure to subscribe in this channel and hit the bells so you can get the notification once I release some new content. This video is made especially for you that just started with containers or would like to start with containers. If you have some more experience or knowledge about containers, also stay here, maybe you will learn something new. If that's your case, leave your comment, hashtag I learned something. And hold on for just a few minutes, because this is a very practical video. I will show you the life cycle of containers, how to create, how to execute the containers, but I just need to give you a quick background so you can think the best of this content. I will start right away with the most important question of this video, and this question is, what is a container? What the heck is a container? Maybe this is an obvious question for you, but I once knew about a big event where the people in the room spend a whole day watching a lot of awesome talks, awesome lectures about containers, and in the end of the last session, someone raised their hands and asked, what is a container? A container, and hold on your chair, okay, make yourself comfortable and prepare to know that a container is a process. Okay, a container is a process inside a Linux operation system. On Linux systems, we have a kind of process called cgroups. It's a name for control groups. And what is a cgroup? Is a process where we have resources allocated for that process. What kind of resources? Memory, CPU, storage, and things like that. When we create a container inside our engine, for example, a Docker, what we are really doing is allocating resources to a specific process. Is a kind of a virtualization. It's not a virtual machine, but it is a kind of virtualization. And these resources that are allocated to those processes, those smaller processes called cgroups, they are shared resources. They are resources that the host share with this process, these cgroups, these containers. That's why we call that when we create containers, we are increasing the density of the usage of those resources. And when we say that we are increasing the usage of the resources, it's kind of a Tupperware. I don't know if you are familiar in your country with Tupperware. That is those small plastic boxes that we put stuff on the refrigerator, for example. So when you are storing food on your refrigerator inside boxes, inside Tupperware, inside of plastic boxes, you are isolating that food from other foods in the same refrigerator, so they won't mix the smelling, they won't maybe if you have some kind of leak inside the refrigerator, I hope not, but if there is, the leak from one food will not mix to each other, and that way you can stack stuff inside your refrigerator, because if you don't have any kind of cover, you can't put one thing on top of each other. Okay, so you just miss that space that is on top of a plate, for example. But when you have boxes closed, well covered, you can stack them, and then you can increase the density, the usage density of that resource that is a rack inside your refrigerator. That's the same case when we are using containers. When we isolate those processes, you are increasing the density of usage of your resources. So by that way, you have a smart way to use the resources. So that was our first question, what is a container? And now our second question, what is a container for? I would say three main points here, and they are isolation, environment consistency, and transparency for operation. So the first one, isolation, it's because of the Tupperware part. So when you have all those processes really separated from each other. You can treat each one of them as they were a machine, a kind of machine. That's why I'm insisting here that they are a kind of virtualization, but with a lot of less resources consumption. The second reason for using containers is environment consistency. Who never heard about, oh, that worked on my machine? When you are using containers, you can avoid it works on my machine, because now you can run in your machine using a container and then got the same application, the same container, and run on your test environment. That's the same environment, and then you got the very same container and put on production. By that way, you have the same environment in whatever environment you are testing. Okay, doesn't matter if you are developing, testing, or running production, you can have the very same environment. You will have your environment much more stable than if you are developing on your laptop, Linux, MacBook, Windows, whatever, and then putting on tests that is a Linux X, and then on production is a Linux Y. By using containers, you can avoid this problem that we have when using different operating systems. And the third reason for using containers is transparency for operations. And what is that? When you are delivering applications to your operations department for putting on production or putting on testing or whatever, if you are using different technologies, your operation teams needs to know that different technology. So for example, if you are deploying applications using Java, PHP, and Go, the operations teams will need to know Java, PHP, and Go. But if you are deploying applications using containers, guess what? Your operations teams needs to know only containers, because it doesn't matter what is inside a container. The way to deploy a container is the same. And if you ever heard about containers, maybe you heard about Docker. And why Docker is the most famous and the most used container engine so far? Maybe for two reasons. First, and for me is the most important one, because Docker was the first to bring a standard when we talk about containers. We had different implementations and standards and whatever, but Docker was the first one to bring a standard that could be applied to whatever operating system, to whatever vendor, whatever technology that would use containers. Docker was the first one to bring that standard that could be reused for everyone. For me, the first reason and the main reason of the success of Docker. And of course, the second reason is because once we have a standard, everyone can use it. So professionals, vendors, companies, projects, or whatever, everyone could start using containers by using Docker, and then its popularity increased a lot since the beginning. Alright, so let's jump to the screen and I will show you how create your container from scratch. Alright, so remember I told you that container is a kind of virtualization, and in the same way we need something that we call image. We need, before creating containers, we need to create a container image. A container image is something like an ISO image where you have a pre-built file that will be the base to create when we talk about virtualization, a virtual machine, and when we talk about containers, a new container. So to create a container, you need to create first an image. And an image is a structure of your container. It will have the operating system, it will have your application, and you will have how to start the application. And as we just said that Docker is the most famous, most used, I will base my presentation here on Docker. To create a container image using Docker, the first way that we do it is by using a Docker file. There are other ways I won't cover here today, but I will cover by using Docker file. Let's create our Docker file and let's edit this Docker file. So here it is, our Docker file. It's empty, of course, because we need now to build it. And the first section that we are going to implement here today is the from. And what is the from? The base image. And what the heck is a base image? You could create your container by downloading a Ubuntu, for example, and installing all the patches and the packages and whatever you need, and then put your application, and then you're gonna have a container with 8 gigabytes of storage. And we don't want this, okay? We would like to create our container as smaller as possible. And when we are using the from keyword here, we are saying to the Docker engine installed on my machine that, hey Docker, there is an image that someone already prepared and built and put on the cloud, and I will create my container image based on that image. Yes, you don't need to start from scratch, because there are millions of people around the world building containers every single day, and whatever technology that you are using today that runs on the cloud, and I'm sure that the maintainers of the technology that you are using already created some basic image for containers that you can apply on your project. In my case here, as I told you, I am using a Java application, so I will base my container image here on a container image made for Java applications. So what am I gonna do right now? So I will go here to my terminal and execute Docker images. The Docker is the client for my Docker, my local Docker, and images will list all the images that I already have on my machine. So here I have two images for OpenJDK. I have this version 8 and I will have here this version 11. So what I'm gonna do here is to copy this image right here and use as my base image. So I will create my container image here based on the OpenJDK 11. That's how we start here. Okay, so the second part of my Docker file, it's where I will add my own application. So I will use add. All right, and here I will got some file of my application and will add to my Docker file, to my container image. And my application here is this one. All right, so I will add this file, and inside my containers I also have folders. So I will put to deployment. And I can change the name of application. So to not use this whole name, I can just call app.jar. But it is a Java application, and my Java application has dependencies. So I need to also add those dependencies to my container. If I go here to the folder, I have here this folder called lib. So I will add my lib folder, all the files inside my lib folder, and will also add to this deployment and lib inside that folder. All right, so by that way I'm adding both my application and the dependencies. And now I can go to the CMD part where I can really execute this application using this container. And how do I execute this application if I was not using container? I can go here and this application is just running. So I will just copy this command, and before paste, just put these brackets and now paste here, and I will split this command right this way. And remember that my application is not this anymore, it's this inside the container. So I will copy here. Let's jump to the terminal and now let's build a container image. How we do that? By using docker build command. And I will use the option T. It's for tag, so I will tag this image as my first container. And then we put just a period here. By using the period, I'm saying to the Docker that in this very folder, I have a Docker file that can be used to build this image. Let's execute it. Done. My image is built. Okay, there are a lot of steps here. I won't cover today, but it's made successfully. If we use here the Docker images, we have my first container right here built. Now I have a container? No, I don't have a container. I need to create a container based on this image. So we'll copy the name, and we have two main ways to create a container. The first one is Docker create and using the image. Alright, my container is done, it's created. And now what? It's working, I can use it. No, it's not yet because it's not running. Once you create a container, it's not yet running. And if we go here to Docker PS, is the command to list the container. There's no containers because this container is not running. So I need to use the option A. The A will list all containers, not only those who are being executed. So here it is our container. I will just get the ID here and will Docker start container. Now our container is really running. How do I know that it is running? I can, for example, I have the ID here. I can Docker logs. Here I have the log of this container. Alright, it's really running. And here is saying that it's running on this address, okay, port 8080. So maybe we can try this port. So localhost 8080. Hello, I know this application has an endpoint called hello. Failed to connect. Why I have failed to connect? Because I have not exposed any port of this container. Remember, I told you that a container is an isolated process, and all the resources of that process that I would like to use from outside, I need to say it specifically. So in this case, to use the port 8080, I need to tell Docker, hey Docker, I would like to use the port 8080 of this container. So what I'm gonna do right now is to remove this container and create another one exposing the port. All right, so let's learn how to remove this container and then create the new one exposing the port. I will do Docker rm. Look that we have a mistake here, we have an error, an exception, and it's saying that I can't remove a container that is running. I have two ways to solve this. I will use the first one, the safe one, and then the second part I will use the not so safe one. Here I will use Docker stop, other command for you. I will stop this container. Alright, now I can safely remove this container. So let's create this container again. I will use Docker run. Remember that I told you that we have two ways to create containers. The first way is the Docker create, who just create and not start the containers. And here we have the Docker run, who create and start the containers, okay? Docker run, I will use the option P that will expose the port, P for ports, and I will expose this port right this way. Here I'm saying get the port 8080 and expose as 8080. I could use here whatever I want. I could expose as 9000, for example. Okay, I'm not gonna do that. I will use just 8080. And the base image is my first container. And then my container is up and running. And hopefully we have here this port available. So let's hello. All right, hello it is. My container is up and running and responding because I have exposed that port. And now one last part here. Remember that I told you when we tried to remove the container on the last part, we couldn't do it right away because it was running. And then I showed you how to stop the container and then remove. Now I will show you how to force a removal of container even if it is running. What I'm gonna do right now is Docker PS and got the container ID, and then we just use it Docker rm F, and then boom, it's in a kill and remove the container. All right, now you know what is a container, what is good for, how to create, how to stop, how to build an image, how to force stopping, and how to expose a port. And then now you can create your own containers for your own application. So let's do it, let's code, let's create our containers. I would like that this video would be a start from a whole series about containers. But first I need to know what you need about it. So please leave your comments here, what kind of content, what kind of scenarios, what kind of usage of containers you would like to watch here in this channel, so I can prepare this content for you, because without you this content has absolutely no meaning at all. If you like this video, don't forget to hit the thumbs up so it can be more relevant to more people. And if you don't like it, leave a comment and tell me how can I improve in the next one. And again, don't forget to subscribe and hit the bell so you won't miss the next content. See you next time. Bye bye.